This screen is visible to you?
Yes, sir.
Today we will discuss a molarity topic. What is the meaning of molarity and formula problems we'll see in this topic. First of all, molarity can be denoted by capital M. Can be denoted by capital. What is the definition if you observe here? How many moles of solute present in 1 liter of solution? The number of moles of solute present in 1 liter solution. How many number of moles of solute present in 1 liter of solution is called what? Molarity. This is the definition. For example, I have taken here 1 liter of solution. This is 1 liter of solution. Now here I am adding what? Here in this, not I am adding anything. In this, if you have 0.1 mole of NaOH in this 1 liter solution, you are having 0.1 mole of NaOH. Then the molarity is equal to how much here? The number of moles of solute will be equal to molarity when you take solution 1 liter. Now, if I write the formula for this one, molarity is equal to number of moles of solute by volume of the solution, isn't it? Generally taken as molarity. But here, remember, this is in liter. This is in liter. Okay? This is mole already. N is nothing but called mole. N is equal to what here? Mole. Right? Now, we can also write this formula. N is equal to number of moles of solute. V is equal to volume of the solution in liter. But most of the case in the problem, we'll take volume of the solution in ml also. In that case, the formula can be written as what? In another way also. Let me discuss that one also. But meanwhile, we complete the units. Now, what are the units for the moles? Moles only. What are the units for the volume? Liters. Therefore, the units for the molarity is what? Moles per liter. Next, I said here, we can change this formula into ml here. Let me take this one. Now, already we know one thing. Mole is equal to, what is the meaning of mole? Mole is equal to weight by molar mass. Weight of the solute in grams, gram molecular weight. Molecular weight in terms of gram. Okay, molecular weight in grams. For example, NaOH, molecular weight is 40. So take 40 grams. Into, isn't it, 1000 by volume of the solution in ml. Because 1 liter is equal to 1000 ml, therefore you take this formula. So most cases will take this formula only. This is important formula for calculating the molarity. You have studied this one in the 11th class also. Okay. Even you study in the yesterday topic also, you can't remember. So remembering what last for you. Now, molarity is equal to, we are writing in short form like this. This is the short. Same formula, but short form. Weight, gram molecular weight into 1000 by V in ml. Now, if they ask weight of the solute, now most of the case what happened, they ask weight of the solute also. Just rearrange this one. Weight of the solute is equal to what happened? Send these two terms isn't it? Here and this 1000 over here, like this, you'll get this formula. This is no need to remember here. Just remember this formula, then everything will be okay. Next, one more formula we'll take here for dilution process. M1 V1 is equal to M2 V2 here. If you have number of moles, you can divide this one with N1 by N1 2, but same solution, only to divide this. So for example, I have taken like this. This is first solution. Here molarity is equal to M1 and value of the solution is V1. And here what I am doing here, I am adding some water to this. I am adding dilution means what you have to do better? You have to add water. Dilution means adding of water. Adding of water. You are adding water here. In this case, now V1 becomes here what? V2. Now M1 becomes what here? M2. And these will be equal here. Now this first solution, second solution will be equal in terms of M1, V1 is equal to M2. So this is the main formula you have to remember. Understood? Nidhi is there? Nidhi. Nidhi is there or not?
Yes, sir.
Ma'am, I'm calling you what since what when I start the class you are not replying.
Sir, you were not audible in the beginning.
Beginning onwards I'm speaking and many of them say what happened, it is audible for them. What about your yesterday exam? Shall I put absent? Because whoever not submitted, 4 students not submitted, for them I put absent only. They are actually Parth, Priyanshu, Nidhi, Nikita K. Till now they didn't submitted the assignment. 4 members. So I will, this is not assignment beta, this is exam. I put absent only. Assignment I can give 1 or 2 days time. For exam also, isn't it? I will put absent. That's it. Next, if you observe what happened, neutralization reaction beta. Neutralization reaction means anybody knows beta? Varsha, can you say what is neutralization reaction beta? What is the meaning of
Yes, sir.
neutralization reaction means by beta? What is the meaning of neutralization reaction? Do you know? Say yes or no. No problem for me. If you say no, also no problem. I will ask some other.
No, sir.
Acid
Anybody?
base.
Acid and base in equal amounts.
The reaction between acid and base is called what? Neutralization reaction beta. Okay. So for example, I have taken HCl, okay, and NaOH I have taken. So definitely this reaction is called neutralization because this is acid, this is base actually. So we got NaCl plus water, you got. These are the products. So for this case, I want to calculate molarity of HCl. I can calculate molarity of NaOH also. By using which formula beta? This formula. M1 V1 is equal to M1 V1 by N1 is equal to M2 V2 by N2. Now why I have taken N1 and why I am not taken here N1? Because this is dilution process beta. In dilution process, isn't it? Same solution only. Same solution only. If I take here NaOH, here also it is NaOH only. So there is no difference in the moles here. What is the difference it is taking place here? Only that water I am adding. When you add water, concentration will change. M2 will change here. And both will equal now. This both will be equal. M1 V1 is equal to M2 V2 only. Because when you change the value, isn't it? Molarity what happened? That will, isn't it? Changes here. So cumulatively what happened? One is what happened, you are adding, molarity will decreases. No, if you add volume, what happened? If you add water, volume increases, molarity decreases here. So cumulatively what happened? Nothing will changes here. One is increasing, other is decreasing, means what happened? Cumulatively what happened? Nothing will change here. So M1 is equal, M1 V1 is equal to M2. Just don't need to go through in detail. Simply remember M1 V1 is equal to M2 V2. Now in examination, for example, they given molarity of HCl, okay, volume of the HCl, okay, and volume of the NaOH, and they are asking molarity of NaOH. They are asking. In that case, you have to take this formula. How many moles are there? 1 mole. How many moles are there? 1 mole. For example, if they given like H2SO4 plus NaOH gives rise to Na2SO4 plus what happened? H2. If they given like this, 2 moles you take. Here we get 2 moles. Now in this case, they given M1 value, V1 value is given. Here M2 also given. They're asking V2 now. Here. They're asking here V2. Just imagine they're asking V2 now. Now in this case, M1 V1 by N1, M2 V2 by N2. Now based on this equation, now N1 is equal to how many moles beta in this one? N1 is equal to how many moles beta? 1 mole. N2 is equal to how many moles beta?
2.
2 moles. Like that you have to take it. Understood? So this is about what? Formula for neutralization reactions. Okay? Right? For mixed solution of molarity. For mixed solution means what happened? So you see here, I am taking what happened? 2 solutions I am taking here. HCl. It is also just imagine HCl only. It is also HCl. It has M1 V1. It has M1 M2 V2. Okay. If I add these 2 solutions, both are HCl only, but I am adding these 2 solutions here. So what is the resulting solution? Molarity. Add these 2 solutions. Okay. What is the molarity of resulting solution? In that case, you take this formula. M1 V1. This one you add. This one you add. Divide with what? Total volume. For example, if it is having 150 ml, this is having something 50 ml. Add these 2, we get 200 ml. Again, M1 V1, M2 V2, we have to add. So this is for mixed solution. So molarity for mixed solution, molarity for neutralization reaction, molarity for dilution solution. All are look same only. M1 V1 is equal to M2 V2, but you are adding, dividing with N1 and N2 here. And here what you are doing here, everything you are adding and you are taking dividing with total value. So useful formulas better, all these formulas, you write in your notebook, all these formulas, so that you can do n number of problems. We'll do some problems also in this one. Next. Now you can also rewrite this formula like this also. Why? Because already you know molarity is equal to what is the formula beta? N by V. Already first formula we discussed this one. Based upon this, N is equal to what we get beta. N is equal to what we get cross multiplication M into V. So same formulas here. Different number of formulas. Yeah. But fundamental formula is only one formula. That formula, if you remember, all we get actually. We can easily derive that. Now sometimes what happen? They may ask millimoles also. Moles, millimoles. What is the difference beta? Millimoles means 10 to the power of -3. Okay. In that case, you take volume in liter. When you take beta, if they ask mole. Volume, if you take in ml, the number of moles will become now here millimoles, because milli is what CGS unit. ml is also what happened? CGS units. Both will be same like this. Liter is SI units and mole is also something what happened? Same like that. So this is the millimoles of solute. Same formula. This is the formula. We are getting this one. Next thing, if you observe, again, if you observe molarity formula beta, N by V. Correct or not? Now, what is the relation between molarity and volume beta? Kiran? What is the relation between molarity and volume beta? Kiran? Time waste for me.
Sir.
Asking Kiran.
Yes, sir.
Time waste only. You are saying yes, means time waste only.
Sir, relation between?
You are not listening, that means.
Sir, listening.
What you are
Molarity
doing
and
right now? Right now, what you are doing better? Right now, what you're doing, beta? The question is, what is the relation between molarity and value?
Sir, can you repeat one more time?
I'm not writing what what is that? Ram Koti. Repeating what 100 times. It is there on the screen. What is
Sir,
the
M is directly proportional to 1 by V.
M is directly proportional to 1 by V. And what asking my question? What is the relation between molarity and value? Molarity and value. Till now I asked question 6 times I repeated it. So this is the what way of listening of class. Hmm? Doing some other works. You are busy with some other works.
No, sir.
Leave it. You asking question to Kiran what happened? Almost all what happened. You don't get any answer. Otherwise, waste time for me. Correct or not? Venkatesh,
Yes, sir.
what is the relation beta? Molarity and value?
Sir, molarity is used to calculate volume of
My
solution.
question, listen better. My question is what? What is the relation between molarity and value? I'm asking the relation. I'm not asking the use here. I'm asking the relation. What is the relation between molarity and value?
Sir, N upon V.
Beta?
Sir, N by V.
N by V is the formula beta. N by V is a formula. I'm asking question is what? What is the relation means आप कैसे बोलते? Tejas? Tejas is there? Absent, I think. Tejas. Devashish?
Yes, sir.
What is the relation beta? What type of relation is there between molarity and value? अभी 10 बार हो
Sir,
टाइम हो गया.
no, sir, when molarity increases, volume decrease.
ना रिलेशन क्या बोलते हो उसको? What relation we have to call? Directly. It is inversely or directly proportional.
So inversely.
Sir, inversely.
See why I asked this question, because whether you are seeing the screen or not, this is the reason I have asked this question. Whether you are seeing the screen or not. In screen, it is clearly showing that molarity is inversely proportional to value. Okay? Clearly it is mentioned here. Molarity is inversely proportional to value here. So even though it is visible, you are unable to speak, you are unable to give answer. So I want to see how much you are paying attention. For that reason, I asked question here. So it was from 5 minutes waste for me. You can no use. Now, if you observe what happened, when you increase the value, molarity will decreases. For example, I have taken a solution whose molarity is equal to 1 molar beta. Okay, volume is equal to how much here? Something what happened? 2 liter beta. 2 liter volume, 1 liter molarity. Now, if I add some water to this one, when I add water, volume will increases or decreases beta? Anybody? If I add water, volume
Increases.
will increase. Then, so for example, I added 1 liter of water. Just imagine I added 1 liter of water. Now volume is increased to what? 3 liters now. And molarity M2, the resulting solution molarity M2 will now convert into something 0.8 molarity. something it will decreases here. Because in formula, if you observe, M is equal to N by V. Molarity is equal to N by V. Now, M and V both are inversely proportional to the value. So now if I heat, that means if I increase the temperature, okay, solution will evaporate. Otherwise, no change. If I heat, for example, I am placing 1 molar NaOH solution, isn't it? In outside I am placing, or inside also I am placing, because of the temperature in environment, external temperature. I am not heating anything. External temperature, solution will get evaporate or not? Solution get evaporate or not, better?
Say operate.
Definitely what happen? Evaporates. Why? Because the simple thing, if you put some water over the table, small drops of water over table, after some time definitely it will be evaporate, right? Now, so you are making some 1 molar of NaOH solution, you kept in the laboratory, that one. After 10 days, the molarity definitely will change. The molarity definitely will be changing. Because of what? Heat. Even if you close also, because of the heat, temperature difference, some will be evaporated here, isn't it? So based on the temperature, what happened? The volume definitely what happened? Decreases. Then in that case, molarity what happened? Increases here. Understood? Molarity with respect to temperature, when you observe, when temperature is increased, it depends upon the volume, no? So that what I am saying here actually. So molarity will change with respect to value. Now volume depends upon what here? Temperature. What I am saying, molarity depends upon volume, and volume is what? Depends upon the temperature. So molarity changes with temperature because volume depends on temperature. Understood? This is very important beta. We'll see this one again in the molality also. With rise in temperature, volume what happen? Increases or decreases? Tell me beta.
Decreases.
Now, if I observe what happened, this one, just a minute. Container I am taking here. Charles law, tell me better. Anybody knows Charles law? Charles law better. Anybody knows Charles law? Boy's law, Charles law? Nobody knows. Charles law.
So volume price.
What?
No, sir.
Nobody.
Volume directly proportional to temperature.
11th class you study in the states of matter. V directly proportional to temperature. Now when you increase the temperature, value what happen? Increases.
Increase.
Now what you see, observe. For example, I have taken some water over here. When I heat, what happen? Water gets evaporate. Water gets evaporate. Correct or not? Then volume of the water will increase or decreases? When I heat, what happens?
Decreases.
Water will be evaporated. With respect to this container, the amount of water will be decreased. It will be evaporated. But what is Charles law? Volume is directly proportional to temperature. This is for gas molecules. Charles law for what? Gaseous molecules. But here what is happening, when you increase the temperature, in this case, in the case of the solution, what happened? We are taking what happened? Volume is increasing here. Okay, when you decrease the temperature, volume also what happened? Decreasing. Based upon which law we are taking? Charles law. So when you consider this one, temperature and volume both are directly proportional. Now based on that, with increasing the temperature, so volume directly proportional to temperature, molarity is inversely proportional to volume. Now based on this, finally we can say with increasing the temperature, because you see with increasing the temperature, molarity decreases. With decreasing the temperature, molarity increases. Isn't it? So this is the thing we can identify based on these two formulas. Based on these two formulas. Next. What is the meaning of decimolar beta? Anybody? Deci means what? Decimolar means what? 0.1 molar. In examination beta, they will give decimolar of solution. They don't give the like V1 is equal to something. They will simply decimolar they will give. Meaning of this one 0.1 molar. Centi means what? 0.01 molar. Milli means what? 0.010. 10 to the power of minus 3 molar. Semi means what? 0.5 molar, isn't it? Deca means what happened? 10 molar, isn't it? This is important for you. Generally, they will give deci, centi like this here, or millimolar. They don't give molarity is 0.0001 here. They simply say it is millimolar. This means if they say millimolar in question, then molarity is equal to how much you take? What? 0.001. Sometimes they say what? Semi-molar of HCl solution whose value is what? 500 ml. Like that this. Semi-molar means what actually? 0.5 molar. Understood? So all of you please remember this concept. Okay, this is important for you. Right? Now we'll do more next one. Problems here. Will the molarity of the solution at 50 degrees Celsius same, less or more than molarity at 25 degrees Celsius beta? Can you give the answer? At 50 degrees Celsius and 25 degrees Celsius, the molarity will be same or less or more.
Less.
Just now we seen what happened. That order. Based upon that order, what happened? What you are taken? Molarity at 50 degrees Celsius will be definitely what happened? Less when we compare with what happened? 25 degrees Celsius. What is the reason? Molarity will decreases with what happened? Respect to temperature. What does it mean by what? 1 molar of NaOH. What is the meaning of 1 molar of NaOH beta? I told you one thing. Molarity formula. Number of moles present in 1 liter of solution. Here 1 molar means I can say here what? 1 mole of NaOH present in 1 liter of solution. Present in 1 liter of solution. Correct or not? That is called what? 1 molar. For example, if they say what happened? 2.5 molar. How many moles of solute present in 1 liter solution beta? In this case?
2.5.
2.5 moles.
2.5 moles.
Okay. Now, molarity you can take in terms of moles for 1 liter solution beta, because definition just now we have discussed about that. So, the meaning of 1 molarity of NaOH means 1 mole of NaOH in 1 liter solution. To make 1 liter solution is called what? 1 mole. 1 mole is equal to 40 grams. Why? Because molarity formula is equal to weight. Weight by gram molecular weight. Molarity is equal to how much? I said what happened? Molarity is equal to how much beta? 1. 1. Okay. Right. Next, weight. Gram molecular weight of NaOH, how much beta? 40. NaOH gram molecular weight 23 plus 8 plus 1 is equal to what? 40. Now weight is equal to how much beta? 40 grams. So in this way, if we know the molarity for 1 liter, easily we can calculate what? Weight also. What happens to the molarity of the solution if the solution is heated? I'm heating the solution. So what happened to the molarity beta? Molarity will decreases due to rise in the temperature and increase in the volume. Isn't it? So this is important beta. Very important. Next one. Can you say which is the correct one beta? Correct statement.
Both A and B.
Both A and B is what? Because volume and you can see easy directly. Volume, temperature, both are what happened? Directly proportional. Normality is not there in the beta. Normality is not there. So that will discuss. We don't discuss this one because normality is there in this does not in not syllabus. Leave it. We'll discuss next what happened molality beta. Yeah, that I will make separate video. Molality.